Hello, so today we are going to do this problem, which is part of Leetcode daily challenge, scramble strings. So what this problem says is we get a string S and we want to convert it. So basically we want to check if we can scramble it to get T. And the way we scramble is by a defined algorithm here, which is first, if the length of the string is 1, we should just stop and check. Now, if their length is bigger than 1, we want to split the string into 2 non-empty substring at any random index, right? It doesn't matter. And then we divide it into 2 parts using that index. So x and y, such that s is equal to the combination of the 2. And then once we divide, we randomly swap the 2 substring, or we decide either to keep them in the same order or swap them. And by swapping them, meaning just taking the left part, making it on the right side, and taking the right side, making it on the left side. So either we keep them in the same place, which is, it would be equal to, if the first part was x, the second part was y, keeping them in the same place would be just concatenating both, so getting the original string. Swapping them here would be to take the right part, put it in the left, and then the left part on the right. So it would be y plus x, okay? And then we can recursively apply this into each of the 2 substrings, right? So we take x and then we apply it into it. When we do x, we divide x, we can apply it also to the 2 parts of x, right? So we do this, we can do this recursively. And given these 2 strings that are of the same length, we return true if we can scramble S1 to get S2 with this definition of the scramble, and return false if not. So let's take a look at an example just to make sure we understand. So let's say if we have S1, great, and S2 is RGEAT, like this. So one possible way to get S1 to be equal to S2 is, so first we divide, let's say at index 0, 1, 2, at index 2. And so we get, this is the first part, this is the second part. So let's say in this decision, we make the decision to keep them the same, to not swap the order. Okay, so they are still the same. Now, each part will also recursively get divided. So GR get divided, and so into 2 parts, right? And then eat, we can choose random index. So for example, let's say we choose index 1 in this substring, and so we divide it like this. So for this one, so then next, let's say for the first portion, we decide to swap it. So R becomes to the left and G to the right, like this. And remember, once you are down to 1 part, like R here, we are done, because when length is 1, we just stop. Okay, so now we have this RG, and then we have this one. Okay, so let's say we make a decision here to swap. So we made the decision to swap. Now we go back here to these 2 parts. Now this one is 1 letter, so we can't swap it, but these 2, we decide to divide them. Okay, and let's say we keep them in the same order, right? So now comparing to S2, now they are the same, right? These 2 are the same because of this swap. So we can compare R to this one and J to this one, and then eat. Okay, and so now they are the same. The only thing we actually did was this swap, and we were able to get S1 to be equal to S2. So that's roughly the idea here. Now let's see how we can solve it. Okay, so how do we tackle this? So let's say, for example, if we take the first string, great, right? And then the second string, this is the first example, is like this. So what do we need to do? So you can see what we do is first we divide, right, like this. And then we take that division, and then we divide more again. So we divide like this, these 2, and then we decide also to divide this one here, right? And then we can also go even further. Once we divide this like this, then we can decide also to divide like this. But the first thing you might think of is, okay, how do I decide where to divide, right? And the thing is, it's tricky to find out where. And so whenever it's tricky to find out where, let's just try all of them, right? So the first thing is try all I options to divide, right? Okay, so that's the first part. Now the second part is swapping or not swapping. So remember, each time when we divide, we have two choices. We have either to say s is equal to x plus y, or we have to say s equal to y plus x. Okay, that's the swapping part. Now the other thing we want to do, remember the initial goal we need to keep in mind here is that we want to convert this S1 to S2. That's the initial goal, is to see if we can, using these scramble rules, if we can from S1 get to S2. And so to do that, every time we divide, let's just keep in mind our goal. So for example, when we recurse on GR, let's pass RG. Because if we pass RG, then if we do both combinations, we can compare, right? Okay. And now the other so the first part I said is we will just try all I options, right? Now we have these two options. Which one we should do? Well, each time let's just do both and see what we get, right? So do both. Okay. Okay, so we know we'll just try all the options, really brute force solution. Now the second question becomes, how do we, so you can see, for example, here, we decide to divide here, and decide to divide here. How do we pass that recursively? Well, the thing is, for example, let's say for this eat, what are the bounds for this eat using the original string? So if we have here, we have 0, 1, 2, 3, 4. What are the bounds? Well, for eat, for example, if we divide at e, what is the first portion for the second half? Well, it's from 1 index 2, right? 2. If we make this inclusive, it's index 2 to 2, right? And then if we make it inclusive again for et, it's from index 3 to index 4, and this one is from index 0 to index 1. So you can see for each string, right, we can't assume that the first index is always 0, because some cases it's because we divided the first and then we divided again, it may not be 0. And so what you notice here is we actually need a left side and a right side each time. So here what this means basically is that we need, for the first string S1, we need to know what is the left boundary and what is the right boundary each time. Okay, so that's the first part here. Now, since we are comparing against S2, remember, whatever we do for GR, we need to compare and see if we can get RG, right? So basically we also know if we split, we want to check if it's equal. So what we can do is also, just as we are passing the left boundaries to compare against for S1, we pass the boundaries to compare against for S2. So that would mean, for example, here the comparison is going to be from 0, 1, between 0, 1 and 0, 1 here, right? And so we also pass S2 left and S2 right, the boundaries for it, because also for, let's say, when we are comparing against E here, right, we need to pass 2, 2, like this. When we are comparing against 3, 4, we need to pass 3, 4, this part here. Okay, so with this, we know that our function will need to have these here as the parameters, okay? And so now the question becomes, how do we recurse? How do we recurse and keep dividing? We know the base case is when the string length is 1. We can just stop and check if they are equal, but what are the options? Well, let's look at it. So S1, let's say this is the block of the string. S2, so we said we will try all i's, right? All I options. So the first case, right, is when we will keep them in the same place, which is x plus y. So let's say I is somewhere maybe here, right? So in that case, right, what should we compare against? Well, we should just compare this side, right, against this side, of course, after recursing, and then we compare this side against this side, right? So this is the I position here. This is I position. So how do we do that? Well, and we need to recurse on these two. So what this means basically is, let's say our function got called with scramble for S1 left and S1 right, and then S2 left and S2 right, okay? So these are the bounds. So this would be S1 left, this would be S2 left, sorry. This would be S2 left, this would be S2 right, this would be S1 right, S1 left, right? So what we are comparing is, well, we need to recurse on this side here. What is this side? Well, this side is just, for S1, it's going to be S1 left to S1 left plus I, right? That's exactly what this portion is because we stop at I. And then what is this portion? Well, this portion is just for S1 first. So for S1, it's S1 left plus I plus 1, right? Because it's the next spot. And then S2, S1 right. Now what about for S2? Well, for S2 is just this position first, which is S2 left. Ends at S2 left plus I, the same way as S1. And S2 left plus I plus 1. That's the position next to I, is just I plus 1. So this is left, by the way. Just to make this super clear. And then the last position is just S2 right. Okay, so this is pretty straightforward because it's just x plus y, because we are keeping the same order, we are not swapping. But we will recurse, and maybe for this substring, maybe we'll reverse the order and swap this one to be here and this one to be here, right? Maybe, and that maybe gives us the right answer. So that's why we try all of them. Okay, so what's the other possibility? Well, the other possibility is y plus x. Now, for this I, by the way, we'll try all options. So let's say, for example, for this one, which is length 4, we'll try to break here, we'll try to break here, we'll try to break here, we'll try to break here. We'll try to break in multiple, in all the I options. Okay, so for the second case, which is the case where we do x, we do s is equal to y plus x. So how would that work? So for the case where we do s is equal to y plus x, let's draw it out. So S1 is going to be like this. Okay, and then we'd have our S2. So what does it mean for, so let's say this is the I position, right? So this means basically this is our X and this is our Y. So what do we want to compare against? Well, swapping basically means that we want to compare this portion against this portion, right? Because we will put y first, and then we want to compare this portion here against this portion. So what does that mean? So that means for the left side, we will pass, because this one is becoming the left, we are comparing against the left, so for the left, we will pass this one for S1, and then for S2, we'll pass this one, so this would be our left. And then for the right side, we'll pass this one and this one. Right? So how do we do that? Well, that means we will recurse in a different way here. So how does that happen? So first for the left side, so recurse 1. So that's going to be from this position to this position. So what is this position? So this is the S1 right. So it's just going to be from S1 right, minus I, right? To get to here, right? We need to subtract I. Because remember, this I basically dividing means that what it's going to mean for us is that the length is going to be I, right? The length is going to be I. And so we go from S1 right minus I to the end, because this is the right portion. And then for the S2, we will compare it against just S1 left, because we start from the beginning. S2 left, all the way to here, which is S2 left plus I, right? And then for the second part, right, for the second recursion, we'll compare against, this is the X part, so we'll compare this one against this one. So it's mean for S1 is going to be S1, just the remaining part of this is going to be s1 right minus I minus 1, right? Because this is just what's left after taking s1 right minus I, right? So what's left is going to be, so we go from s1 right minus I to s1 right. So what's left is from s1 left to s1 minus right minus I minus 1, right? That's just the remaining part. Now what's the remaining part of this one? Well, we stop at s2 left plus I, so it's going to be s2 left plus I plus 1 all the way to the end, which is s2 right. Okay, I did write it here with right instead of just L and the R, just to make it more clear, right? And so this is the clever thing we are doing here, is that instead of actually going and swapping, we'll just pass the boundaries, different boundaries. So when we compare the right side here with the left and the left side here with the right. That's the idea. And so we'll just check if these two will end up getting us scrambled, getting us s1 equal to s2, because each time with our recursion here, we'll stop when we have one letter. And so, for example, in this case, when we swap R and J, we'll compare this R with this R, it will be good. We'll compare this J with this J, it will be good. We'll compare E with E, it will be good. A with A, it will be good. T with T, it will be good, right? Because we'll go all the way down until one letter. So that's the idea here. I hope this makes sense, because instead of swapping here, all we are doing is we are changing the boundaries that we compare against. And what helps really with knowing all the values here is just to remember that no letter will be left out, right? And so if we start from right minus I to s1 right, that means for the second part, we'll need to go from the left all the way to the spot before this one, which is s1 right minus I minus 1. Right, and then the beginning is just s1 left. And similarly here, because we stop at s2 left plus I, we need to start from the next position, which is s2 left plus I plus 1, and we need to go all the way to the end, so we need s2 right. Okay, I hope this makes sense, but this is pretty much the idea here. Now let's implement it and make sure it passes. Okay, so let's implement the solution we saw in the overview. So we need a recursive function, let's call it just Scramble. And we said the boundaries we will pass is both the left side and the right side of each of them, of each string. So it's going to be s1 left, s1 right, and then the left sides and the right side of s2 as well, right? And we know our base case is if there is just one letter, and one letter means that the boundaries for s1 are equal. We don't need to worry about different length because the problem says the strings would have the same length. So here in this case, well, it's valid only if we can get, if they are equal, right? If the same letter is equal in both strings. So s1 left, s1 left is equal to the same one in the same spot in s2. If this is the case, then we return true, otherwise we return false. Okay, so now we said we'll try all I positions. Now, what are the valid I positions? Well, the substring we have goes from s1 left to s1 right. So the possible length of I we have are just the length of that string, so starting from 0, right? So it's going to be s1 left like this. So these are the possible length we can have. Okay, so now, remember, these, by the way, are inclusive bounds. So this means that the string starts at s1 left and stops at s1 right, exactly. Because otherwise, we may end up with an empty string, right? So these are inclusive bounds. Okay, so here, now, the length, this means we will divide such that the length of the left side is I and the length of the right side is I, right? So length of left side is I, and length of right side, yeah, and length of right side is the remaining, or yeah, pretty much, right? And so how do we do that then? So the first normal case is, the first case is s1 is going to be x plus y. So in that case, we can just check that once we divide into these two parts, right, each one of them can get us equal to s2. So we divide with I. So let's say x to the left is going to be s1 left, right? To get a length I is going to be all the way to plus I, right? And then for the right side, it's just going to be, because we are not reversing the order, it's going to be the same. So s2 left to s2 left plus 1. We are not changing anything in this case. Now, what we need to do it for all the string, right? So what's the remaining part? So the remaining part is going to be starting from where we ended here, right? But we need to do plus 1, so that will go to the next letter, all the way to the end of s1, which is, in this case, the substring is just up to s1 right, okay? And then what are the boundaries for s2? Well, just the remaining part of this similarly. So it's going to be s2 left, here plus I, sorry. So it's going to be plus I plus 1 to go to the next letter. And then the second part, so this is going to be just s2 right, okay? To get to the end. Okay, so if we are able to scramble and get to it from these, we return true. Now, otherwise, the second case, which is case S1, going to be divided like this. Well, we said we will take the right part and put it on the left. So that's going to be S1 right minus I, all the way to S1 right. So the right side to the left. And then the left side is unchanged because we are comparing against it. So it's going to be just S2 left plus I. And then for the remaining portion, so what's remaining here? So remaining from S1, which is the X part, is going to be just the one before this one. That's going to be our end boundaries. But we need to start from the beginning because we shouldn't leave any letter not checked, right? So we start from the beginning and then we go all the way to this boundary here of the Y portion. So S1 right minus I minus 1. And then for the second part, it's unchanged because we are comparing against S2. So it's going to be just the rest of this one, which is going to be left plus 1 all the way to the end, which is S2 right. Okay. And that's pretty much it. Now, if we are able to get this case to be scrambled to S2, then we return true. If we go through all options for I and we are not able to do that, then we return false. And now we just need to call our recursive function. So we want to start with the entire string from the beginning, of course. So that's going to be 0. Let's say n is the length of these strings. So S1. So we'll go all, because these are inclusive bounds, we shouldn't put n, we should put n minus 1 because that's actually the last index. And then for the right side, it's the same. And then we return those. Looks like there is a typo somewhere here. Okay, let's just simplify it like that. So we get this. This looks good. Still like that here as well. Okay. Looks good. Now, we'll get time limit exceeded here because with these variables, we will end up calling this function with the same parameters multiple times, right? So the easiest way to do that in Python is just to do LRU cache. But you can also just cache. You can also just use a hash map with these parameters, right, as the keys for your map. So let's run, let's submit, and this passes. Looks good. But yeah, that's the idea pretty much. It's just doing brute force, but making sure we apply all the cases. I will let you do the cache using a hash table. It should be pretty easy to do. But yeah, that's pretty much it for this problem. Please like and subscribe, and see you on the next one. Bye.